Good morning, everybody. Welcome to today's Meeting of the Minds webinar. Today we're talking about digitalization, opportunities for new forms of participation in urban transportation planning with Chris Zegras from MIT. My name is Jessie Feller-Hahn. I'm the Executive Director of Meeting of the Minds. We're a global thought leadership network and platform with year-round digital and in-person programming to connect global urban sustainability, innovation, and technology leaders across sectors for sharing best practices, tools, and solutions. We do that through our blog, a monthly webinar series, pop-up events, workshops, meetups, and conferences. Our 11th annual Fall Leadership Summit convenes October 23 through 25 in Cleveland, Ohio, where we will be continuing the conversation from today's webinar. You can find out more information about that at meetingoftheminds.org. Today we have Chris Zegras, who's our presenter today. He's an Associate Professor of Transportation Urban Planning at MIT's Department of Urban Studies and Planning. He teaches, leads large-scale research, and consults on a range of topics from data collection to behavioral analysis, integrated land use transportation planning and modeling, and project and policy analysis. He's lead principal investigator for the Future Urban Mobility Interdisciplinary Research Group under the Singapore-MIT Alliance for Research and Technology. He's also an executive board member of the Bus Rapid Transit Center of Excellence. So with that, Chris, take it away.
Thank you very much for the opportunity. I want to thank everyone who's joining this afternoon or this morning or evening, wherever you may be. And as Jessie so graciously said at the beginning, I'm going to speak today about well, you can see the title there, and I'll explain a little bit what I mean both by the idea of digitalization and then public participation into urban transportation planning. Before I go too far, however, of course, I don't want to leave this to the end because I may not get there, and it's very important for me to thank the various people who have contributed to the projects that I'm going to talk about today. First, Anson Stewart, who is soon to be finishing or graduating. He's finished his dissertation, PhD student here. This work actually builds on some work that he initiated as part of his master's thesis several years ago. A team of students at MIT, colleague Professor Caesar McDowell, Quan Butts, a former student who was one of the design and user interface experts, colleagues from the Media Lab, Ryan Chin from Changing Places Group, or formerly Changing Places Group, our local NGO partners, Livable Streets Alliance and the Nuestra Comunidad CDC, and our private sector partner, Conveil, including, and some of these folks are no longer with Conveil, but Matt Conway, Andrew Bird, Trevor Gerhardt, and Kevin Webb. And finally, I would, of course, like to thank our funders, BRT Center of Excellence, who has supported this work from the very beginning, the Barr Foundation, who supported the Roxbury workshops that I'll talk about today, and Transit Center, which is supporting our ongoing work to explore some of these tools and their capabilities to help NGOs build capacity around issues of public transport priority. Okay, well, without further ado, first, this idea of digitalization, what does it mean? Digitalization is generally recognized as this idea, the adoption or increased use of digital technology or computational technology by organizations, industries, private sector, society more generally, and it's essentially reflects the way our social and our enterprise lives are changing in the face of digital communications. So here you see, for an example, the idea of 3D printing, virtual reality, and so forth. In transportation, I would probably be willing to bet that when we think about digitalization today, we tend to think about autonomous vehicles. You can't have a transportation discussion these days without talking about autonomous vehicles. I will not be talking about those today. But also you can think about digitalization as manifesting itself in a range of other lightweight infrastructure-less traffic management technologies, where we're going to the cloud-based light signalization schemes, for example, real-time predictions of traffic conditions, or the personalization of public transportation, which is often known as mobility as a service. These three examples are some research ongoing as part of the Future Urban Mobility Group. As Jessie indicated at the beginning, this is a large research center that MIT has in collaboration with the Singapore government, based in Singapore. But the form of digitalization that I want to speak about today relates to this basic idea as epitomized in the smartphone. We, the consumer, or the user, the body politic, we've come I would be willing to bet that everyone on this call probably has a smartphone, and this really symbolizes what we have come to expect about the digital economy and the increasingly digitalized world. We have the world in our fingertips, we think. We have data collection capabilities, control capabilities, a world of knowledge at our fingertips, and this is how we increasingly expect the world to function in real time. Sensing and computation at our hands. Now, I would like you to think about this in light of this. This is, a very gratuitous, perhaps, picture of a public participation process here in Massachusetts. And this is still a very typical process. It tends to be static engagement, one-directional, dry, arguably superficial, and this misses great opportunities, in my view, for co-creation of alternatives. So by co-creation, I mean that users, that operators, that industry experts, that planners can come together and devise solutions. This is a practice that's increasingly known in various industries, including in some transportation industries. We as citizens have higher expectations than this today. Again, thinking about this idea, we have the world at our fingertips. So the question is, can we, how might the digitalization start to change the dynamics as represented in this picture? Okay, so a little bit of contextual background to today's talk. I'm going to briefly describe two experiments we've done around this idea of digitalization and some of the technologies we've been testing for participation. And our background is the Boston metropolitan area. Like many different transit operators and agencies across the United States, the Greater Boston is the MBTA, Massachusetts Bay Transit Authority, and like many others, we are in a constant state of financial crisis. And at the same time, we have relatively poor levels of service. So these are bus service from AM peak, taken from a GPS feed. And a couple of key things identified here. Well, first, obviously, red is slow, less than 10 miles an hour during the peak. You can see MIT. You can see Boston City Center here. And you can also see Dudley Square, which is the heart of the Roxbury neighborhood, which is one of the places where we did one of the experiments that I will describe in a moment. The key here is to note that green tends to feed higher income areas, and the red tends to feed, not entirely, but lower income areas, places of traditionally underrepresented groups and minorities. And the question then becomes, how can we change these conditions and actually improve public transportation with and for the people who need it the most? The MBTA has attempted this over time at the surface level. Our biggest, most ambitious effort to date is the Silver Line, so-called bus rapid transit. I would not personally call it BRT. There's a couple of segments of it which we might call BRT. But this was introduced in 2000, and essentially this is the type of infrastructure it represents. There's some indications of lanes. There's some indications of a different type of stop, but it doesn't share the characteristics of BRT that some of us have come to know well. Here's an example of a station in Mexico City. You can see the level boarding, prepay boarding, dedicated right-of-way, coordinated signals, including with pedestrian crossings and so forth. Here's another example of the Ecovia in Quito, Ecuador. Just one more example here of the famous Transmilenio in Bogota. This idea of mass transit on wheels at the surface. Now, Boston has tried to be more aggressive in bus priority in the relatively recent past. The highest profile failure, I'd dare to say, was the effort to promote bus priority in exactly some of that red corridor you saw earlier, southern Boston, Roxbury and Mattapan, again, traditionally African-American communities. And this was a result of this was an initiative that was a result of the desire to spend federal stimulus money at the end of the 2000s. And essentially, the community was tired of being told the solutions that were going to be given to them and essentially opposed it. In the wake of this, the Barr Foundation, a private foundation based here in Boston, took a different approach to try to identify bus rapid transit corridor potentials through a non-governmental oriented initiative, the BRT study group, and that initiative identified 5 potential corridors that had promise both in terms of high demand, high current delays, and arguably space for BRT to actually be inserted. And so the first experiment I'm going to now talk about was initiated in the aftermath of this program, where essentially the Barr Foundation asked MIT whether we could see if new technologies might help the participatory planning process around this idea of introducing bus rapid transit. So that leads to the first experimental workshop I'm going to talk about, which took place in the Roxbury neighborhood, Dudley Square being the center of it historically. And these experiments took place a couple of years ago in the fall, in the North American fall. We set out to test one basic hypothesis, that tangible interactive planning tools in public engagement workshops enhance learning. Now, we are trying to measure both single and double loop learning, which I'll talk about in a moment. Now, that's the explicit hypothesis we set out to test. Our underlying hypothesis is that this leads to better planning outcomes, but we can't test that because, well, we'd have to actually see outcomes over time and only be able to observe those much later. But this idea of single and double loop learning is important. I want to spend a moment to talk about it. So single loop learning is what we traditionally think of as learning, problem solving. We're given a problem, we figure out some way to solve it, and then we move on. Double loop learning implies deeper learning, where it's not just fixing a problem, but rather the process of learning itself leads us to fundamentally question our objectives, fundamentally question our assumptions, and the values and beliefs behind what we're trying to do. Now, I would argue that this is actually much more important when it comes to trying to engage the community in coming up with alternatives that can satisfy mobility demands across the metropolitan area. So the mechanism underlying these two hypotheses with respect to tangibility and interactivity have been revealed in the literature. In terms of tangibility, there's evidence that shows that this allows people to think more rapidly, to kind of continuously revisit ideas, better grasp spatial relations, which is very important when we think about urban transportation planning, and in fact, help us discover new things. Interactivity, in turn, helps foster our imagination. It's been shown to help different users align with respect to, there's almost a sense of gaining empathy for other perspectives. This helps us engage, and this ultimately might help us change our attitudes and even our later behaviors with respect to, in this case, transportation or urban mobility. And so to test these hypotheses and whether these underlying mechanisms seem to have some truth to them, we combine two different tools. And I'm not sure how well the videos will show to you all online, but we had two tools in this first set of experiments. The first tool was Cityscope, which is the tool developed by a Changing Places group at the Media Lab, and then the second is a tool we call CoAccess, which was developed within my group here at MIT, and it's an accessibility mapping tool. So the key element of Cityscope is essentially the tangibility happens because people use, the users essentially play with a tangible block everyone is familiar with, Lego, and then this is linked to a microsimulation tool, which is projected onto the model to show dynamics. A CoAccess, in turn, is a interactive mapping tool which runs on a web browser. And in the cases that we've used it to date, we have this deployed on a large screen, horizontal touch screen, with the idea of trying to simulate a workshop setting. The architecture of CoAccess, essentially, as I mentioned at the introduction, we worked with Conveil and we continue to collaborate with Conveil. We're essentially, CoAccess is a user-facing interface designed to be engaging to a relatively layperson audience, and it rests on the Conveil backend. And if people are interested in the technical elements of this, I'm happy to talk about them in the Q&A. But the way we conceptualized these workshops were at essentially 3 stations which aim to represent 3 different scales of impacts that bus rapid transit might imply for a citizen, for a resident. The first 2 tools, the streetscape simulation and the neighborhood simulation, use Cityscope, the Lego tools, and then the regional simulation was Coaxis, this larger interactive regional scale mapping tool. Excuse me. So, just one note. The neighborhood simulation represents the neighborhood of Roxbury, so it's built to scale, and that model was actually built by a group of high school students from Roxbury the summer of 2015 leading up to the workshops. Now this video attempts to show some of the design process, and I apologize because for some reason the videos are extremely jumpy today. But this is kind of just the way we conceptualize and eventually design the tool. I won't belabor this too much, but I wanted to give you a sense at the very end of this video. So here's Phil Tin, one of the former students working on this, building the street scale model. And this is, representing the intersection. This is coding the back end. We're running the simulation here using Sumo, an open source traffic microscopic simulator. And you can see finally the results of that with the simulations projected onto the model. And here the options being, you could change the bus stop, which implied changes in the right-of-ways for the buses. You could add bike lanes, which implied removing parking, and so forth. So we piloted this several ways. This was actually our first pilot that we did together with the BRT study group. Then we tested it, since we're here at MIT. We had numerous student test groups of the various scales. And then finally we, and again the video is jumpy, I apologize, we worked together with a local community organization, Nuestra Comunidad, and the idea here was we trained facilitators from the community so they could actually run the workshops, the idea being this would enhance the possibilities for peer learning. So this is just an image that tries to show how the street scale functioned in the workshops. Essentially, you could change, as I mentioned earlier, for example, bike lanes or the placement of the busway at the curbside or in the median, and then we projected some estimated results from the microsimulation on a dashboard that was adjacent to the model itself. So you can see, for example, changes in the travel time by car or by bus, the changes in waiting time, and the number of parking places that were removed. A similar approach was taken at the neighborhood scale, so you can see an image of the model there with landmarks highlighted by flags. And then once more, you could change station location, station type, corridor type, and once more the dashboard would present different elements of performance such as pollution levels, average speeds, cost of investments, and so forth. And finally, the regional scale, the users could choose a location, and then you see here an isochrone. This is a amount of area one can cover given a certain amount of time via the public transport system. So the user had the option to change routes, to change a stop type, to change a stop location, to upgrade headways or frequencies of vehicles. And then once more, there were performance metrics that were presented in terms of accessibility, the number of jobs accessible within a certain amount of time. And then once more, these were related to the costs of operations or investment or number of vehicles or number of drivers and so forth. This is just an image which shows, for example, a user playing with the neighborhood scale model. Now, I want to talk briefly about the experimental design. So since we were trying to learn the effects of these tools, back again to those hypotheses, testing the degree of learning, we had a pre-survey and a post-survey. So it was a pre-post design. We did not have a control group. But there was one key element of this at the pre-survey, because we were not sure ahead of time. We wanted to have a broad cross-section of society. We were not sure how familiar everyone would be with navigating on online maps. At the point of intake for the workshops, we had people enter in something like a travel diary digitally on a map. Now, it wasn't a specific diary, but we asked, well, where do you live approximately? And then they could navigate to, well, where do you work, or where do you normally places you travel to, where do your loved ones live, and so forth. Those points of interest were then fed right into Coaxis. And now this was a key element of personalization, because then when the users got to those stations, they could pull up their own activity spaces, which immediately, the thought being this would immediately personalize the tool for their use. At the same time, it allowed us to get a sense of how easy different types of users were able to navigate web-based mapping. And so we ran through for the entirety of the workshops, lasted for about 2 hours. And well, here you can see the basic layout of the approach. I'm not going to get into the survey. We can belabor that if we'd like to. And during the Q&A, we had about 51 total participants, 45 of which actually gave us valid responses, and you can see we're pretty skewed. Even though we tried to be representative, we're relatively skewed to a younger cohort in terms of the participation. Now, in terms of responses, you can see here that people seem to reflect that they learned a lot. They kind of appreciated the degree of openness in the dialogue that was enabled by the tools. It seemed to have some indication that there would be buy-in to the types of ideas that were discussed. So this idea, some evidence of co-creation. Whether people did not feel that they were actually had very strong teaching role themselves, they did seem to have some evidence that they might be more empowered with respect to their agency and ability to change the system. With respect to the ideas of single and double loop learning, we found very strong evidence of both, using indicators that are somewhat basic if you look at the questions, and we can argue as to whether or not these are necessarily the best indicators of to capture double loop learning, especially in terms of learning about the topic. Now here it's interesting because we found a fair amount of learning with respect to elements of BRT. This is comparing responses pre and post the survey. Pre and post the workshop. Now, of course, there's a limitation with respect to these findings because we don't have a control group. So it's only pre-post. We don't know whether you would have learned just as much about BRT if we gave you a pamphlet or a book and you read it for a few hours and came back and answered a survey again. So clearly that's a limitation. With respect to belief in impact and agency, individuals did not reflect an overwhelming amount of change in the sense that if you look at these two questions, like, while there was evidence of learning, there doesn't seem to be an overwhelming amount of change that I have a greater chance of having an impact on decisions, and I have greater agency in making things change. Okay, so I want to quickly look at the three tools we use. With respect to usability, there was a very strong sense of this, the street is the streetscape model that's depicted here, that this tool was very easy to use, very easy to understand, and people could relate to this because you could take away a bike lane or add a bike lane or take away parking or change the location of bus stops and the bus lanes. However, with respect to relevance, that the tools actually reflected issues that people cared about, and that the tools seemed credible, the regional scale tool scored the highest, this interactive mapping tool. And so this led us to believe that this tool Coaxis might actually have traction with enhancing planning processes and agencies and organizations that are interested in planning, and so that led to the subsequent workshops that I'll talk about in a moment. But a few key design lessons I think that we took away before we moved on with continuing with the development and deployment of these tools. For Coaxis at the regional scale, there was a lot of value to being able people to match what they saw with their own personal experiences. So having people insert their own points of interest really made this relatable. The fact that people could play with this in many different ways and compare this to their own experiences, like, oh, well, from Roxbury Crossing to get downtown, it actually doesn't take me 25 minutes by the T, it takes me 45 minutes by the T, and it led to a discussion about some of the assumptions underlying the models. With respect to what people really found to reported finding most compelling, comparing was really important. This idea that you could say, okay, how far can I get in 30 minutes versus how far can I get in 45 minutes? Okay, what if I'm in downtown versus what if I'm over at Harvard Square? So that was extremely valuable. And again, the second most important thing was impact visualization. Here is just an example of the personalization where people are selecting their own points of interest and being able to see how the performance of the transit system behaves. So, for example, if you can see here an image of a users where they work, where their home is and where a loved one is, and then how far they can get given different time assumptions, like if you have an hour to travel versus an hour and 15 minutes to travel. Again, underlying this is the idea of you would be taking public transit. This just shows unfortunately the audio you cannot hear, so I'm not going to belabor too much, but once more, this was the type of discussions that were enabled by the tool. So before I move on to the second use of these technologies in a planning workshop setting, just a couple of limitations with respect to this first experiment. While we try to be representative with participation, I mean, those who choose to show up at a workshop are those to choose to show up at the workshop, so we're not guaranteed that this is actually representative of participants. There was a lot of difference in the workshops that we carried out sequentially because we learned how to do them better, and just by the nature of, this was a Monday, a Wednesday, a Friday, a Saturday. As I mentioned earlier, we didn't have a technical, we had no control group, and there was still a lot of problems, I think, with this idea of, okay, this is interactive, and yeah, I can play with the tool, but what's really underlying it? What are the assumptions? So there was still accusations and concerns about whether this was just a new form of a black box model. So now I'll turn to our second stage workshops. These were carried out last fall here with Livable Streets Alliance, a local NGO. This was work supported by the Transit Center that was interested in seeing whether coaxis could help build capability within an NGO for, in this particular case, developing interest in arguing for bus priority. We had several hypotheses here that we wanted to test, but the one I'm going to actually focus on is we were interested in whether the way you presented results mattered to the users. So there's two ways you can imagine understanding the impacts of transportation improvements. Accessibility, such as, well, how many jobs might I be able to get to within an hour, is, that isochron-based approach, versus the more traditional measure, which is travel time savings. We hypothesized that using locational accessibility would actually be better for users in terms of understanding the impacts of system improvements, and that this would then increase enthusiasm for transportation projects. Well, public transportation projects in this case. So once more, we took a workshop approach. We had about 40 participants, a little bit more than 40 participants over a week in several different workshops. And here our approach was slightly different. We weren't testing different tools. We were just testing different versions of the same tool. So once more, it was random assignment. You came in, you were assigned to the accessibility version where your benefits were measured in terms of accessibility versus the point-to-point version where benefits were measured in terms of travel time savings. We used 5 corridors that the Massachusetts Department of Transportation has identified in its bus priority measure. We coded these into the system and then allowed users to change specific characteristics. You could modify the running time, the dwell time of the vehicle, and the headways or the frequencies. And then the point-to-point version, you can see here that people would select an origin and a destination, and then we would show on the left-hand side, hopefully you can see the travel time savings and which components of that savings, where that savings was coming from, whether it was waiting time or running time. And then the accessibility-based version, a user would select an origin, and then the isochrones would represent the deltas, the changes in the accessibility given the improvements. And then once more over here, the kind of number of jobs, increased number of jobs one could gain access to were represented. In the interest of time, I can't get into the specifics of the research design the instruments we use to measure, but basically we did find evidence that the accessibility version did kind of mitigate disappointment about the impact. So overall, the findings from the 5 corridors that we tested, which are corridors that MassDOT has identified a priority, people were left a little less than awed because the benefits did not seem very high. But looking at this from an accessibility perspective essentially translated into less disappointment. It did seem to increase enthusiasm for bus priority, although there's a fair amount of variability in it. But a very important piece that came up out of the discussions in the workshops were the tool itself, or the idea of accessibility did not reasonably reflect the actual elements of user experience. And I think the next 2 graphs are important to show. So underlying this tool, and I haven't talked about this in detail, but I'm happy to in the Q&A, we use a static GTFS feed. So this is the digital representation of the public transportation service. So it's static. It's just the scheduled service that the MBTA says it will operate. However, we can actually see using historical performance of the service that's obtained through the automatic vehicle location service system that the T has on its vehicles, how the service actually varies in time. So you can start to see, for example, this is an attempt to show the distribution and reliability based on history of service. And so this is something we're interested in looking at now. Okay, might actual reflections of reliability as actually operated might change the way people perceive the credibility of the tool. Overall, in conclusion, I want to say that we did find through using these various types of tools that there's some evidence of learning. These learning mechanisms include the ability to interact and converse with others, develop some empathy, and relate to people's points of view. And also because this interactive tool, you can actively engage and question the underlying data. We found evidence that the interactive accessibility mapping supports some dialogue, but there's questions about the credibility of the tool. If, in fact, the tool says you can get downtown in 25 minutes, but the user says, no, every day I do that and it takes me 45 minutes. And, you know, whether or not these tools can actually overcome this idea of the illusion of inclusion, by that meaning, well, because I'm at the dialogue, I actually do have a role, but in fact, planning and decision-making continues in a status quo nature, is yet to be seen, because none of these have been employed in any formal processes. These have all been academically spurred with nonprofit support and voluntary workshops. And so all of these findings, of course, should be taken as indicative. I am going to end there only in the interest of time, because my clock tells me I've already gone over by 1.5 minutes, and open it for Q&A and happy to discuss future uses if in fact that comes up in the Q&A. But I will now thank you and pass back to Jesse.
Thanks so much, Chris. Fantastic stuff. So yeah, we're going to move into a Q&A now with Chris. So feel free to type your questions into the questions panel and your control panel on the right. We already have a few questions that have come in. A couple of you have asked if there's going to be a recording of this webinar, and yes, we always record our monthly webinars, so it will be available on our website either later today or tomorrow, so be sure to check back the website for that. And a couple questions. One question for you, Chris, from Bruce Donnelly about assumptions. Regardless of the tools, if you start with a given set of assumptions, you tend to get the same family of solutions. Can you give an example of how participants were able to challenge the assumptions effectively? For instance, were they able to impart information to the team that revised the problem space you were considering?
That's a great question. So just to give a very simple example, and this will allow me to get I realize I probably skimmed very quickly over the underlying data here. I showed an image. So we have 3 key sources of data that are underlying the coaxis tool in any case. The GTFS feed, so that's the General Transit Feed Specification. That is the way that transit services get digitally represented in Google Maps, for example. that's a schedule-based representation, so it basically is what the T says it does, what the MBTA says it operates on the number one bus. So that's one assumption. We have OpenStreetMaps also underlying this. So again, the whole idea being these are open source tools and open database tools. And then finally, we have, in this case, we represent the jobs, and there we use the EPA loads data set, which is some representation of jobs by earning category. So now, but a key way that assumptions were questioned were, for example, with respect to waiting time. So if someone said, well, this is where I live, and I'm interested in seeing, well, if I can get there in a certain amount of time, and the user said, no, that never happens. And it always takes me 25 minutes, not 15 minutes. And then it would lead to, well, a discussion of why that might be. And for example, a key question was how headways or frequencies related to waiting time. And one of the assumptions we used, or in our representation of the public transport service, was that you would arrive, you could show it, for example, if you arrive just after the last vehicle left. We kind of made our first version of it worst case scenario. So assume you arrive just after the bus left, so you have to wait another 10 minutes. But you can change that assumption, and we discussed that. We discussed the implications, so it started to get people thinking about this idea of headway. Another key assumption had to do with bus bunching. So this is, very typical here in Boston, and I'm sure other people have experienced it elsewhere, where you wait for the bus, the one here, the number one bus, which runs down Mass Ave right in front of my office, and you wait for the number one, and then 3 number one buses come by. Now that's not scheduled service, that's just service, that's bunching that accumulates because of the unpredictable conditions on the street. And so that's another assumption that can be questioned, or that that the assumption is that buses are running as they should, not as they do. So that led us to this idea, or this need, that we need to try to show actual services, which we were able to do in subsequent versions, as opposed to schedule service. So we're using GTFS-Real Time, or historical data, as opposed to schedule data. Another key thing, I think, is that OpenStreetMaps, the underlying tools, transit analysts, conveyance tools, assume you're walking on a certain network, but that walking network might not be what a particular user is able to use or can actually use, because the street map walking network might not actually reflect true conditions in a given neighborhood. I hope that partly answered the question.
Great. Thanks, Chris. Yeah, great. A bunch of questions from people about how this fit into a larger planning process in Boston, and also a follow-up question from me is, what's the next iteration of this in Boston, at least? Is this being considered by MBTA for larger scale, more neighborhoods, or are you guys working with BAR to do this in other neighborhoods? Give us the next 2.0, as well as how this fits in the larger vision for the city.
Yeah, so I can't speak formally for the city. I can say that Mass DOT, under which the MBTA rests in terms of authority, has been working on this vision, on a future planning for public transit in the greater Boston area. They did a workshop actually here at MIT, a public engagement workshop a couple of months ago with, I think about 200 participants, and they actually had on display there a version of Conveyal's tool. So I don't know whether they plan to actively incorporate these types of tools into their planning processes, but they certainly are interested. But I can't speak for, we've also spoken with MBTA. They were very involved in, people from the MBTA were very involved in our early pilots, and, had said, oh, this would be great just to have a tool like this in our office so we could kind of even talk internally about this. But at the moment in Boston, we're not continuing any deployments of Coaxis since our Livable Streets workshops. At the very moment, we're testing. We've just launched an experiment to test this in 3 other cities in the U.S. The big difference between what we've done previously, and now is we're trying to see whether this tool has any traction remotely. Meaning, since it's just a website, we were doing it in public settings with the idea that people talking together will create a new conversation around public transit, but that's also very time intensive and labor intensive and asking of people time to come to workshops. So we have now deployed this virtually with the online walkthrough facilitation with video to see whether this has some usefulness, even if people want to use it on their own at home. So we'll have more to report on that by the end of the summer. The experiments have just gone live. We're also, I wanted to show, so we also are developing this in Santiago, Chile. We're going to do some workshops this summer there to look at how this can be used to examine new subway lines and new bus system enhancements that the government is planning. So that's going live in June or July. That's the beauty of these tools is, once more, as long as you have the data, a GTFS feed, and some representation of, in the case of Santiago, we're going to use healthcare facilities, we're going to use pharmacies, and there's a lot of interest in, of course, jobs by income category. You can represent underlying interest or underlying points of interest based upon what data you have. And I did want to just say there's one thing. So a colleague of mine several years ago, Sarah Williams, did this project called Digital Matatus, where they mapped the semi-formal transit in Nairobi using mobile phones and developed a GTFS feed there. And we actually, Anson, in fact, entered that into Conveyal's tool, and you can see through this, if you're able to still see my screen, that you can develop a version of this in any setting where you have an ability to represent the public transit system. So that's a long answer to your question.
That's great. I'm glad you brought that up because Jackie Klopp and her Nairobi colleagues will be presenting that exact project in August for our August webinar. So thank you for that, Chris. And she's on our webinar right now listening. So hi, Jackie. Also, can you, Chris? There's two questions about using this for other modes of transportation, subway, self-driving cars, etc. Can you elaborate a little bit more on that?
Yeah, that's a really good question. So the hub, we've gotten a lot of interest in how do we represent other forms of transit, right? And I think the Nairobi indication is one example. So as there's a lot of interest globally about how do we represent semi-formal transit, minibuses or matatus or daladalas or whatever, whatever they're called in their city of interest, services that don't run on necessarily a fixed schedule or on fixed routes. So there's one, but if one can figure out a way to still represent that digitally, then it can easily be incorporated in here. And I think that would actually offer an interesting setting where people could question assumptions. Okay, well, what if we did consolidate stops? Or what if we did regulate, headways? For a hubway, it's a little bit more difficult, but not impossible, but you would have, you'd have to just have levels of performance. I'm sorry, I'm using hubway, which is, the Boston-based version of bike sharing. And I think that's what I heard you ask, right? Did you just say also about like bike sharing, correct?
Sure. All other modes. I think there were a bunch of questions about that.
Right. So for example, bike sharing, you could imagine it being represented in here. There's a large question about how would you reflect levels of service, right? And you could use historical data about origins and destinations via a bike share system to develop speeds and across, different from one station to another, and once more develop similar isochrone-based measures of how far you can get by expanding a bike share system. Now there you have certain questions because reliability is an issue there because, well, you have to know, you have to come up with some way of representing, well, the likelihood that there'll be a bike there if I get to the station, or there'll be a place for me to park my bike when I get to a station. For the TNCs of the world, right, the Ubers, the Lyfts, I also imagine you could have some way of representing this, but of course the big nut to crack there is getting the data from the private operators, from the companies. Hopefully that answers a little bit.
Yes, right, great. I'm going to combine Gary and Rosemary's questions. Could you measure or did you measure And if you didn't, could you in the future measure, 1, the propensity to pay for transit by users, and 2, GHG impact?
Great questions, both. So you could measure willingness to pay. I think if you had a good design in your experimental approach, you could kind of, we played with this idea in designing the workshops when we were trying to figure out ways to make this engaging. One is we thought about, so one way you could imagine willingness to pay is authorities or the body politic. Okay, well, how much should we invest in improving bus frequencies? And then you could give the users, okay, you have $300 million to spend. Where would you spend it and how, based on performance you're observing here? So that would be kind of from an investment or operations perspective. But you could also imagine doing it from the user's perspective. I'd have to give it a little bit more thought. I mean, but it reminds me of an important question that a colleague from South Africa has asked us. We plan on trying to launch a version of this with collaboration with the University of Pretoria sometime starting in the second half of 2017, and they're very interested in having costs incorporated into the measure of accessibility. So not just, okay, how far can I get in an hour, but how far can I get with $5 or Rand in this case, I suppose. So that is possible, but it will require a little bit of creativity. And then the second question was cost, and what was the other one? Oh, GHG impact. Yeah, absolutely. We have a proposal out to try to incorporate environmental performance into here, because you can imagine, if you electrify the fleet, what would that do? So you can show relatively easily emissions as a performance metric based on the static GTFS feed and some assumptions about emissions characteristics. And then you could imagine, okay, well, what do speeds do to emissions, or what happens if you swapped out, electric buses for diesel buses and so forth. So that's definitely an area of interest that I'm very interested in. And I think we could, that could be added to it as relatively straightforward. Right.
Great. And you have a proposal out to some foundation to fund that research? Is that what you said?
Yes.
Good. So, well, we have 1% of our attendees are philanthropy, so whoever's listening, fund Chris. Okay. The next, that was great. Thank you for that. And Gary and Rosemary, hopefully that answered your question. If not, write another one. Question from Yolanda Gallegos. She says, this technology is incredibly exciting. Could the coaxis simulation tool be used not only by the public but also by the FTA to assess eligibility for federal funding for BRT environmental impact, NHPA compliance, etc.? If so, would it be wise to use it in this manner, or is this a uniquely community-based tool?
Well, yeah, so that's a long question. I want to try to emphasize a few things here. So first of all, we designed coaxis as a layperson-facing front end. Now, this rests on a very sophisticated back end that is run by Conveyo. Conveyo has its own user interface that is more geared towards expertise. And so and Conveyo is working very actively with agencies around the world, in fact, in how their tools can be used to enhance public transport decision making. So I would be very surprised, in fact, if FTA isn't probably doing something now. But I would like to mention a limitation of this, which probably did not come through in my presentation given the time. A key piece that this does not replace, in my view, traditional transportation planning tools. I think it could be a complement to them, but this assumes everything else remains the same. So it imagines you could change the public transit service, but it doesn't account for impacts on other users of the street, like cars. And so that's where more traditional transportation forecasting and simulation tools would come in. Now, I can imagine various ways that the two could be integrated in different ways, but we have not looked at that yet.
Great. Good. Okay. That's 3.0 after 2.0. Bianca maybe you already touched on this, how to integrate formal systems with the semi-formal systems. For example, the Dala Dalas and BRT and Dar es Salaam. But do you want to talk a little bit more about that, Chris? Formal versus informal in the tool?
Well, it's a research agenda, and I think it's one we'll have more evidence to talk about, or more experiences to talk about, hopefully in about a year from now. Actually, hopefully someone else is doing this already, but it's on our agenda to try to come up with some means of doing this in the next, starting in the second half of this year. And there's a range of challenges, I think, that will appear there. Like, one is the fact that semi-formal transit, and where it operates, and we have semi-formal transit here in the United States as well. Some of it is actually purely informal, meaning it's not at all, it's under the radar completely. It's flexible by definition, and so it's hard to represent that in a consistent way in any kind of tool like this, because we need some way of representing levels of service, representing that implies how the wait time is, that implies where the stops will be, and so forth. So there's various ways I think that would be quite creative to, as I said earlier, to incorporate such dimensions into a tool like this, and then would lend itself to discussion about the underlying assumptions. And that would really lend itself, I think, to ideally a platform where users and operators and government agencies could discuss together the implications of their various agendas and how they might find new space to cooperate. Now, that's a pretty globally north optimistic perspective, I think, because the politics of semi-formal transit planning in much of the world is very loaded. So I don't think, a tool like this is going to solve those challenges, but it might be able to help push the discussion forward ever so slightly.
Great. Good. Great. Question from Levar. Hopefully I'm pronouncing your name correctly, Levar. Chris, can you talk a little bit more about Dynamit and how real-time traffic prediction works? Is this available to play around with? Can it be integrated into other apps and open source software? Is the GUI-based, web-based, able to be integrated into Google Maps? A lot of questions there.
Okay, so yeah, I want to make clear the Dynamit, which is one of the three examples I alluded to in the very beginning as new forms of how digitalization is helping us to be creative with transportation planning and operations. Dynamit is in fact open source, but it's not very there's not a whole big user support community here. If you're interested in Dynamit, you can look at the ITS lab. Moshe Ben Akiva's group here at MIT and also at SMART is advancing that. And my understanding is you can in fact download the code and run it, but it's not for the faint of heart. But I do want to emphasize that Dynamit is not at all related to the tools that I presented today in detail. Coaxis is running on top of the Conveils tools, which is basically running with a GTFS, and which is much more simple, for lack of a more technical term.
Great.
Yeah, so I would encourage you to look at Moshe Ben Akiva's ITS lab, and you can learn a lot about that technology there.
Do you know what their URL is by any chance, Chris?
Oh, I think it just might be its.mit.edu, but if you Google ITS lab at MIT, it'll be the first thing that pops up.
Great. Thank you for that. And that was one of my next questions for you, Chris. If people want to follow up with you or this work and try to figure out how it could come to their city or how their organization could use it, what's the best way to follow up with you or one of your PhD students?
Well, you can send me an email. I'll do my best to respond quickly. You can also send an email to, send it to me. I'll be as responsive as I can. I mentioned that we have 3 experiments that are just going live, and I think, I'm not exactly sure the sequence, but I think 2 of them might have gone live earlier this week. I'm not trying to publicize them purposefully because we are trying to make these, we're working in close collaboration with local NGOs in each of the 3 cities, and we want this to be under their control. But those websites, there's 3 different web-based versions of the tool adapted to particular transit priorities in 3 particular places. And once those experiments are done, we would be very happy if people looked at them. So I'll make sure that the URLs are made publicly known very soon. And in the meantime, let's see. I'll see if I can maybe. I don't know if you guys can see my screen still.
Yes,
but
we can.
If not, yeah. So coaccess.mit.edu is I believe is our. Yeah. So that's where you can learn a little bit more at coaccess.mit.edu. It's not loading right now, which I'm not sure what that means, but.
Yeah, when those are live, Chris, and you want people to be on them, because I know you have specific user groups, we can send that out to the attendee list here today. People want that.
That would be great. Yeah, that'd be great.
Yeah. And people are asking what your email is, which is czegras, ZEGRAS @mit.edu. So get ready for a few emails, Chris.
Okay.
And we only have time for one more question. Question from Dwayne Roebuck. In cities where they've deployed smart sensors and traffic devices, can this be utilized to potentially show real-time traffic conditions and predictive analytics, or new transit lines or areas of increasing efficiency? Essentially, what is the future around sensors with this?
So that's a very good question. Some of it we're actively pursuing. So I wouldn't say we currently don't represent anything in real time, but we're able to represent historical we can show anything that's been archived. So MIT has a close collaboration, in this case with the MBTA, and so we're able to easily get into the archives of actual public transport system performance, so we can show, for example, accumulated representations of reliability over time, by season, by time of day, and so forth, anything that we've archived through the MBTA automatic vehicle location system. Now, that said, you're only limited in what you represent on underlying maps here based on the data you have available. And we have played with this a little bit. For example, one of the things we want to look at in that proposal that I mentioned to you that, is the relationship between reliability and air quality concentration, right? To test this hypothesis. So are the places where the transit system is performing the worst in terms of people being stuck waiting at stops, is that also where air pollution concentrations are the worst? And thus, get a double bang for your buck, because you increase bus transit speeds, you thus improve emissions, and you also reduce waiting times. So that's something we want to look at. So any data that one has access to in real time that they can then transfer into a digital representation of it could, in theory, be overlaid or underlaid on the what we're showing the user. I don't know if that answers the question.
No, thank you for that, Chris. That's great. We don't have time. We have a bunch more questions we haven't been able to answer, but feel free to reach out to Chris or to us. We will see Chris at our Boston Mobility Summit next month, where you can talk to him in person if you're attending that. And we hope you'll all attend and continue the conversation at our annual Leadership Summit in October in Cleveland. So with that, Chris, thank you so much for this. It's been extremely stimulating and informative.
Well, I want to thank you, Jesse. Thanks also to Dave, and thanks to the Meetings of the Mind team for letting me do this. And I really also want to thank everyone who came this afternoon to participate. Really appreciate your interest.